Dear colleagues, dear friends, good afternoon. Welcome to TrendForce online seminar on Global PV Market Trends 2023. My name is Tang Fangzhe. I'm the moderator. Since the start of this year, we have seen a lot of trade friction, the war between Russia and Ukraine still going on. All those are negative factors for PV. Around the globe, countries are pursuing green growth. Against this backdrop, we have seen new technologies and new products. We have also seen new opportunities and new products. As for the material supply, as for the prices, what trends are we looking at going forward? And what changes will the industry undergo in the future? How can we grasp all the opportunities for investment? All those are hot topics in this industry. As we are still fighting the pandemic, it is very hard to have offline events. Therefore, today we gather here online. We have quite a few companies from China, and we will share their insights from their perspectives. Also, our analysts will talk about our insights into the future of the PV sector. Now, let me give the floor to Ms. Fan Xiaoli from TrendForce. She will deliver an opening speech.
各位嘉宾，大家下午好，我是TrendForce吉邦咨询樊晓丽。首先欢迎各位参加我们吉邦咨询全球光伏市场趋势研讨会。那近年来，随着全球碳减排的一个进程加速，可持续发展的清洁能源成为了主角。随之光伏市场呢迎来了更加火热的行情，大尺寸和大功率的产品应用， N 型技术的未来发展，分布式光伏市场的需求变化，以及产业链内部的供需以及价格的变动等，这些都值得我们关注。企业跨界的热情高涨，那资本市场也高度的关注，所以呢，行业进入了一个新的阶段。但同时，2022年的经济环境发生了变化，也使得我们光伏行业面临着更多的不确定性与挑战。那在全球能源转型以及叠加疫情影响的大环境下，光伏行业迎来了空前的一个发展机遇。本次会议我们也邀请了多家的企业来围绕全球光伏的政策以及市场的一个供需、产业链的价格、技术发展的趋势等多个主题进行分析探讨。希望大家在今天的会议上能够有所收获。最后预祝本次会议圆满成功，谢谢。
Thank you, Ms. Fan, for your speech. I believe that going forward, the PV sector will make a bigger difference and have a brighter future. Now, let me give the floor to April Zhou, an analyst from TrendForce New Energy Research Center. Good afternoon, everyone. I'm April Zhou, an analyst from TrendForce New Energy Research Center. The topic of my talk today is the general situation and the technical prospects of the global PV industry in 2023. I'll analyze supply and demand as well as technical progress in 2023 from other links along the industry chain. We've made an estimation on the annual output and the possible installed capacity in 2023. Judging from the data, the overall supply of silicon materials in 2023 will be adequate and not restrain the whole industry. On the silicon wafer side, the supply of high-purity quartz sand is quite tight, so the actual output of silicon wafers is further restricted. As for battery cells, since the second half of 2022, newly built capacity has been mainly based on N-type technology, and there is great uncertainty in the race of capacity with new technologies, while the expansion of PRC capacity is at a standstill. In 2023, large-sized PRC battery cells may show a tight balance between supply and demand. We mainly focus on the actual output of TOPCon battery cells and the visibility of orders. In terms of film, the tight supply of EVA particles will continue, and POE particles mainly rely on imports. With the increase of N-type demand, the supply-demand relationship of PoE particles is more tense. For other links, high prices are stimulating upward trends in actual output. Based on the actual output data, we estimate that the global PV installed capacity will be between 330 and 360 gigawatts in 2023. Now let's look at capacity, supply and demand plus technical prospects of each link in 2023. The first is about silicon materials. With the gradual release of new capacity for silicon materials, the effective supply of silicon materials in 2023 will be about 1.34 million tons, which can support more than 375 gigawatts of installed capacity and about 505 gigawatts of modules. The overall supply is adequate and it is no longer a bottleneck. However, the actual increase in new capacity will be concentrated in the second half of 2023. Amid strong demand, the supply of silicon materials in the first half of 2023 will be tight. Some new players are subject to environmental impact assessments, technical solution limitations, and many other factors. Therefore, the schedule for releasing capacity has great uncertainty. The development of N-type wafers increases the demand for N-type silicon materials. At present, the majority of N-type silicon materials are imported. The purity of the granular silicon materials produced by the fluidized bed method can only meet the requirements of solar-grade applications. Whether the N-type silicon wafers can be used in the future still needs to be verified. The modified Siemens method can meet the needs of N-type silicon wafers, and the process is mature. It will be mainstream going forward. Now, let's look at the capacity and the technical directions of silicon wafers. Silicon wafers companies will enter a new round of expansion in 2023 in order to consolidate their positions. Leading players will continue to expand their capacity, while new players and second-tier companies will continue to expand their capacity. The capacity concentration level of leading companies will decline going forward. The overall competition landscape will be scattered. The shortage of high purified quartz sand, the raw materials needed in silicon wafer production, is kind of stable, which will limit the actual output of silicon wafers, but it will also help alleviate fierce competition on silicon wafers. The trend of going large size and flaking is quite clear. Large size products will account for over 90% of the whole market next year. The shortage of silicon materials and the high prices also have accelerated the flaking trend. In addition, with the acceleration of technical iterations for cells on the downstream, the penetration of N-type silicon wafers will continue to improve. At present, the overall production of N-type silicon wafers is low, accounting for 8%. With the mass production of TOPCon cells, their share will increase to about 20% next year. Now let me talk about battery cells. In 2023, the capacity for battery cells will continue to expand, mainly based on N-type. By the end of 2023, the global battery cell capacity is expected to reach about 670 gigawatts, up 26% year-on-year, and showing signs of a slowdown. After the N-type market matures, the expansion of battery cell capacity will continue to speed up. The supply of large-sized PRC cells continues to be tight. The steady increase in the share of large-sized modules shipped in 2023 will drive up demand for large-sized cells. It's estimated that the proportion of such cells in capacity will reach 92% by the end of next year. At present, the expansion of capacity is mainly based on N-type, and the expansion of PRC cell capacity has stagnated. In 2023, N-type battery cells will soon usher in a new period. cost-performance ratio is still the core concern. Cost-cutting, efficiency improvement, and the coordinated development of supporting chains are still the main topics. We can observe the capacity and the technologies of N-type battery cells. TOPCon realized the first batch production in 2022 because of its cost-performance advantage. It is estimated that the capacity of N-type battery cells will reach 180 gigawatts by the end of next year, accounting for 26%. If we look at the different N-type technology routes, TOPCon has a good cost-performance ratio at the present stage. TOPCon's production expansion in the industry is radical at present. Its annual capacity can reach about 100 gigawatts next year, accounting for 56% of the total N-type capacity. At present, HJT equipment investment is still very high. It still needs the technology of flaking, silver paste, and target materials to promote further cost reduction. Only in this way can it have more benefits in industrialization. Its annual capacity will be about 47.5 gigawatts in 2023, accounting for 26% of the total N-type capacity. If we look at XBC, LONGi has launched the HPBC technical route, while EcoSolar has launched ABC. This route can make better use of the technical benefits of P-type silicon wafers. Currently, attention should be paid to the yield and capacity implementation. In 2023, the capacity for an XBC is about 32 gigawatts, accounting for 18%. It's estimated that these three routes will coexist for some time. They will jointly replace PRC. At present, the market space is large and growing. The penetration rate of each technology is very low, but there are opportunities. Regarding capacity progress and efficiency of TOPCon, TOPCon's build capacity has reached about 35 gigawatts, and under construction capacity this year is about 67 gigawatts. Judging from projects already announced, the total scale is still huge. At present, the expansion of TOPCon battery capacity is done by existing players. Data from initial production of existing projects is the key trend or the key metric. If the yield problem can be solved effectively, we will have more confidence in the promotion of future projects. At present, the average production efficiency of TOPCon's top companies exceeds 24%. That is 0.5 to 0.8% higher than the average in the case of PRC. And that is expected to continue to move towards about 25% next year. The current efficiency of TOPCon in labs has gone beyond 25%. In April this year, we have seen Jinko announce the current efficiency of its 182 N-type TOPCon battery cells, reaching 25.7%. That set a new record. Now let's look at the capacity progress and efficiency of HJT. At present, the development of HJT has entered a bottleneck period. The build capacity announced by companies around the globe is 11.6 gigawatts. Although there is more planned capacity, there is less capacity planned to be built going forward. The core reason is that the current cost of producing HJT is high compared with PRC. HJT does not show a higher level of efficiency, and the product premium is limited. In terms of lab efficiency, the battery current efficiency of HJT has gone beyond 25% this year. LONGi even set a new high of 26.5%. Recently, Maxwell has adopted double-sided microcrystalline equipment, increasing the current efficiency of HJT and labs to over 26%. When we look at the mass production efficiency, a number of Chinese companies can go beyond 24.5%. With the upgrades of equipment and the mass production of double-sided microcrystalline technology, HJT is expected to achieve 25% on mass production efficiency by the end of this year. At present, the pathways for cost reduction and efficiency improvements in the case of HJT are quite clear. On the silicon wafer end, the development of flaking and half cuts and metallization paste, all those are positive factors. In China, a lot of facilities have been built for making low-temperature silver paste. Costs can be reduced on a larger scale. Now let's look at the HPC battery. There are a few kinds of HPC batteries, including classic IBC batteries, TBC batteries, and HPC batteries. The classic IBC battery can be based on a P-type silicon wafers or an N-type silicon wafer. It can be combined with TOPCon to create TBC or combined with HGT to form HPC, so that we can reap the benefits of all those technologies and achieve higher efficiency. At present, the total capacity for HPC is 41.2 gigawatts, and the build capacity is 2.67 gigawatts. From the perspective of industry development, there are currently mature IBC products overseas, and the industry in China is growing quickly. Overseas IBC battery leader SunPower has its latest generation Maxeon 6, which has achieved a combined efficiency of more than 25% in mass production. And in China, Eiko Solar and Longi have developed a lot of capacity, which can be completed this year. At present, the production costs of IBC and HGT are high. HPC and TBC are expected to further develop only when their technical routes are cost-effective and mature. Turning to modules, global module capacity continues to expand, probably reaching 640 gigawatts by the end of 2023, up almost 22% year-on-year. Among the companies, domestic module makers have expanded their capacity a lot. The module capacity growth in overseas regions mainly comes from moves made by Tier 1 and Tier 2 Chinese companies to improve their capacity in Southeast Asia. In Europe, India, the US, South Korea, and other countries, they have policies for supporting domestic manufacturing. So some local companies there will also release new capacity. With the price of main and secondary materials falling back in 2023, as well as the benefits in terms of scale, costs, and branding channels, integrated module manufacturers are expected to be the first to benefit from the positive factors. In terms of module size, the capacity of large size module capacity is expected to reach 575 gigawatts by 2023, with a market share of 89%. The capacity of modules with a size of 166 or below will further shrink. As market demand shifts, the overcapacity of companies will be eliminated or upgraded, accounting for only 6% of the market. The large-size application scenarios are diversified, and demand for ground power stations is mainly for large-size products. In distributed scenarios, companies are also stepping up the promotion of large-scale products to better meet demand. N-type modules can enjoy the product premium brought by advanced technologies with good benefits, good economic benefits. In terms of module size, the capacity for large-scale modules is expected to reach 575 gigawatts by 2023, with a market share of 89%. The capacity for modules with a smaller size will also shrink, as I mentioned. Going forward, we'll see N-type modules enjoy a premium, and with the acceleration of iterations for N-type technology, the large-size N-type products can be adopted. The module power can reach 700 watts or even higher, realizing a breakthrough, and that's the future of PV. Now let me make a short summary. But before that, I want to say that when we can ensure a 700 watt or higher module power, we can achieve a lot of possibilities going forward for the PV sector. Now let me move on to my summary. First, the bottleneck of silicon material supply is gone. With the gradual increase of silicon material output, prices may trend downwards, further stimulating demand for installation. Second, the supply of high-purity quartz sand is tight, and that is expected to be a constraint on the effective capacity of silicon wafers. The costs of silicon wafers will increase. Third, the tight supply of large-sized PERC battery cells will continue. It is estimated that capacity expansion in 2023 will mainly focus on N-type battery cells, while capacity expansion for PERC will remain at a standstill. The supply and demand of large-size PERC battery cells in 2023 will be in a tight balance, which will focus on the actual output and order availability of TOPCon. Fourth, the supply of particles is still tight, and the fast development of N-type leads to the increase in the demand for POE film. Fifth, under high prices, all links have upward elasticity in terms of supply. Therefore, we expect the global PV installed capacity to be between 330 and 360 gigawatts in 2023. So that's all I want to say here. Thank all of you for listening.
Thank you, April, for introduction, as well as combing through the trend of the PV industry. And the year 2022 witnessed the layout of N-type capacity, especially in terms of HJT as well as TOPCon. And now let's give the floor to Mr. Zhuang Yinhong, the Global Director of Ryzen, and he will talk about the trend of HJT. Now the floor is all yours, Mr. Zhuang.
Hello everyone, I'm Zhuang Yinhong, Global Marketing Director of Ryzen, and today I'm here to explain to you why HJT or heterojunction is a trend of future development. And here are my slides. And this is my outline of today, nothing important here. But what I want to mention is here, there are several trends here. In the HJT market, we will use relatively large silicon chip to make its full use. In terms of energy saving and emission reduction, HJT can help us to achieve the dual carbon goal. HJT has also witnessed a transition from P-type to N-type, so it can easily reach 700 watts of power. And at present, it is developing really fast. And to put in a simple way, this is the general trend to use HJT. So on the whole, taking account of power generation cost and component cost, our focus will be to reduce LCOE, which is also one of our biggest developments in heterojunction. And here, as you can see, this is a trend of industrial technology in development. And you can see here, all kinds of technologies are moving closer to 2.0 and HJT technology. And we are choosing the more advanced technology to spend more efforts in. And selective charge carrier transmission is also an inevitable choice for us to develop high-efficiency solar power. And here is our application to the development of HJT industrial silicon battery. In fact, from aluminum trioxide to PERC, then to TOPCon, we think that HJT is still the future of the battery technology in the short term. And we hope that we can make some upgrade in the industry to bring you a more efficient industry. And next, I would like to talk a little bit about the opportunities and challenges facing us all. And we have the first principles involving from formal silicon to passivation to optimal VOC. And we also have this kind of temperature coefficient. And all of these can generate relatively satisfying results. And if the surface is purified, we can achieve good bulk passivation, low temperature defects, and less activation in the part from amorphous silicon to silicon oxide, then to silicon nitride. And we can see that in the future, it seems that HJT can be laminated with more technologies from various enterprises. So HJT, as explained here, is also the bridge and the platform for realizing laminated technologies. And in fact, we can divide the period in which we discuss HJT into three main periods. For example, back in 2019, if my memory serves right, it should be August and September 2019. We put forward the idea that we want to do the HJT technology because we identify HJT as a future of development. So from 2019 to 2020 and to last year, we were investing in a pilot test line. And we hope that we can have more manufacturers joining us to verify HJT and to gain more experience.
And this year, I think by the end of 2023, we can feel that this HJT industry is developing. Apart from Ryzen, many other manufacturers have also expanded their production scale and provided many HJT products to market. And we think that 2024 should be a skyrocketing period. And we can say that in the future, our cost will be closer to PERC. Therefore, with the large-scale production, the supplementary materials, and the reduction of the non-silicon cost, the market for HJT products will be even larger. And we believe that HJT products will soon reach the skyrocketing period, which will bring greater ROI for investors. And another thing is that under the dual carbon goal, HJT is actually an easily achieved goal for us. Why? Let's look at the China's dual carbon goal first. This goal means that we need to reach the peak of carbon emission by the end of 2030 and strive to reach carbon neutrality by the end of 2060. It means that we need to use HJT in the product. When we use HJT, we can have greater advantage in power generation and the carbon emission will be lower. So we can use HJT to realize our dual carbon goal of carbon peak and carbon neutrality. And now let's talk about one of the key points today, that is why Ryzen can seize opportunity of HJT development. Let's look at this page. From 2019, we took the initiative to walk down the path of N-type HJT. At that time, we believed that N-type would be the future. However, the HJT project, we didn't start the project until 2020, and we also had gradual shipment in 2020. We ranked the first in that year. And at that time, we were still making the 156 watt HJT battery. At that time, we didn't discuss about thinning. By 2021, we started to make another upgrade. During that upgrade, we also got the power test of the TUV SUD. On February 26, the test power of the component reached 606.6 watts. Therefore, in fact, it is an accumulation of experience for us to make such HJT products. And during the first quarter of 2022, after the transformation of our current HJT leader, Dr. Yang, our first 210 thin film HJT product was launched. And by 2022, or the second quarter of this year, we have launched the HJT product called Hyper Eon. I will give you more details later on, but let me briefly mention it here. That is to say, we're actually launching the main product of a 210 cell, and the battery module is worth of 700 watts. By the second quarter of 2022, our product will be launched, and it will take us a while for us to go for mass production. And it is estimated that in the first quarter of 2023 or after 2023, we expected to have this capacity of HJT battery plus module of about 15 gigawatts. And here I would also like to walk you through why HJT efficiency is relatively good for us, because we have struck a world record for 3 times. And on February 26th, we went through a test of TUV SUD, and in that test, the result is 606.6 watts. And on December the 15th, we've also got a high-efficiency first-class component test, and we've got 721.016 watts. That's to say, the cell efficiency could reach 23.65, which exceeded 23.08% worth of the efficiency. This is a relatively high battery efficiency, and ranking the first in the industry. And just now I've touched a little bit upon our accumulated experience, but now I want to move on to the N-type we are doing now. That is Hyper Eon. And first of all, the most important thing is that we are using ultra-thin silicon wafers of 116 mil to 126 mil, and the low temperature technology to make this product. At present, we emit only about 400 worth of carbon emission. In addition, as far as our warranty period is concerned, our attenuation in the first year may be less than 2%, so we can provide a 30-year worth of power warranty. And our product has lower BOS cost and lower LCOE cost. And in the future, both high efficiency and high power products will follow this trend. And our components, the power of our components will reach 700 watts, and the efficiency of components is about 22.5%. Our power generation efficiency will even be higher, and the double-sided ratio is about 85% plus or minus 5. And here are some of the parameters of Hyper-Eon. You can see that it is a 132-piece HJT double-sided module with a power of 700 watts, and the efficiency of the module is about 22.5, and the double-sided ratio can reach 85% minus or plus 5%. In terms of the weight, it is also very light. Because we are using a steel frame weighing about 41 kilograms. And here in the slide, you can see the plan of the whole product metrics of Hyper-Eon. In fact, at present, we only have the 132 pieces of Hyper-Eon for 700 watts centralized ground power station. But in the future, we will launch like 640 watts or 580 watts or even those smaller scale products for household roofs, which will formulate a product matrix for Hyper-Eon. And here are some of the features here for the Hyper-Eon. There are 6 characteristics. For example, we have the lower attenuation and high power generation. Another feature is the steel frame. Why do we use steel as a frame? Because to compare with the aluminum frame used in the original assembly, the steel frame can reduce the carbon emission, and we're also using ultra-low silver paste and 24 main grids and 210 half sheets. And based on the 210 half piece here, I would like to introduce you a little bit about this point here. Because in the future, we will make these 210 half piece product. We can also see we have the four corners here are the same. And now the scale is 120 mil. Why do we use 120 mils? Because in terms of PERC and TOPCon, you can see the scale is kind of 150 mil at present. So we hope that in HJT, we are determined to use better to elevate our battery efficiency, and our aim is to reduce this by 30 mil. So if it drops to 140 mil one day, we are ready to reduce our goal by a further 30 mil to 110. And our yield rate is about 99%, which is still relatively good. In addition, I would like to say something about the 24 main grid. We have done it really early in the industry, and here I would like to explain to you a little bit, because people are asking that what is the difference between the 24 main grid and the OBB. Actually, we are a component manufacturer, and the battery manufacturers also are always talking about the OBB. The OBB emphasized by those manufacturer of batteries, they have no main grid. They only have the 24 negative grid lines, which is not different from ours. So actually, we put forward this idea of 24 main grid earlier than any of these battery manufacturers. But it's because we are a component manufacturer. We want everyone to see our development in components, so we didn't emphasize the difference between the main grid line and the negative grid line. But actually, these two things are the same. In fact, compared with the 12 main grids, it's better to use the 24 main grids because we will have increased contact points. In addition, let's talk about our low silver paste. To compare with the PERC, the silver content of our paste is lower. And here you can see the Hyper-Eon. It can match with different mainstream inverters. And now let's talk a little bit about steel frame. We are very mature in terms of steel frame to compare with the aluminum frames. The carbon emission will be reduced by 6.2 times when we are using the steel frame. And more component manufacturers are using steel frames to realize the environmental protection and the dual carbon goal. And in terms of the whole life cycle, we can reduce the carbon emission by 77% by using steel frame, and the carbon emission of steel can be reduced by 3.5 times in 1 gigawatts compared with that of aluminum. And in terms of the reliability, steel frame has a stronger tear resistance, and here you can see the comparison. The tear resistance of aluminum is about 7,852 N, and that of the steel is 10,355 N. And so the strength of steel frame is better. And corrosion resistance is also another characteristic of steel frame. And we have two characteristics here. One is that the steel frame can be oxidized into resistance, and also it can do the self-repairing. So self-repairing ability can be a better trait to resist the corrosion. And we've also done some tests in terms of low temperature static load test and dynamic test. But I will not further elaborate on that. I only want to tell you that steel frame works really well in this regard. And also we've done a load test. And when the wind is strong, we are tracking the simulation of this frame. And when the wind is really strong, our steel frame has a very good load, has performed really well in the load test. And also, the ultimate load capacity of steel frame is better than that of aluminum frame. The steel frame can tolerate ultimate load of about 5,060 pa. But the figure for aluminum frame is only 4,550 pa. And now I would like to talk a little bit about our company. Ryzen is a relatively time-honored PV module factory, and we were founded in Linhai District, Ningbo in 1986, and we didn't start our journey in solar energy until 2002, and we were officially listed on GEM of Shenzhen Stock Exchange in 2010. And we have been keeping a good performance in the industry, and with the shipment volume reaching 7 gigawatts in the first half of 2022. And in addition, I would like to emphasize our main business. Besides the high-efficiency components just mentioned, we also have downstream power station, smart energy solution, energy storage, non-materials, EVA companies in our own business, LED lighting. And here is our international service network. We have 22 marketing service centers and 6 production bases, one of which is located in Malaysia with 3 gigawatts. And we also ranked among the top in all the component manufacturers of this year, and we may rank 6th or the 7th place globally. And now, since the establishment of our company, we have installed more than 40 gigawatts worth of capacity in components, and there may be more to come in the future. And you can see the revenue is increasing as of 2022. And QC is also an important thing that we really care about, from the raw materials to supply management to the production line. We also highly value after-sales services. High reliability is also one of our business cards. And here, I also want to tell you that we have been certified by National Laboratory in China. Our product are all CNAS certified. And here are all the things I want to share with you. If you have any questions, just feel free to contact us. I'm Zhuang Yonghong, Marketing Director of Ryzen. Thank you. Thank you, Mr. Zhuang, for your sharing. And we know that HJT Hyper-Eon has high efficiency, low resistance, and Hyper-Eon has made great breakthroughs. It reflects Ryzen's efforts and capability in terms of manufacturing PV products. Now let's give the floor to Mr. Chen Dong. and Mr. Chen is an expert in terms of the whole life cycle manufacturing of PV. And his topic is about the global application of the component.
Hello everyone, I'm Chen Dong from China Solar. I want to thank TrunForce for the invitation. Today, I'm going to give you a presentation on the applications of 600 watt plus ultra-high power modules around the globe. My presentation has 5 parts. In the first part, I'll talk about our company and energy transformation around the globe. After that, I'll share information about industry trends, system value, global power generation, plus the reliability and compatibility of 600 watt plus UHP modules. So our company was founded back in 1997. We are committed to becoming the global leader in PV smart energy solutions. This year, China Solar has just celebrated its 25th anniversary. This past April, the cumulative shipments of China Solar worldwide exceeded 100 gigawatts, and that marks a new era. According to third-party statistics, our module shipments ranked number 2 around the globe. For a long time, our company has been one of the leading companies in this field. In the era of new energy, the whole world is committed to carbon neutrality and a high share of renewables in the energy mix. Building a new electricity system around new energy has also been the direction for energy transformation in China. According to the latest estimate of the International Renewable Energy Agency, solar energy is a powerful boost for achieving carbon neutrality. The agency expects global solar power generation capacity to exceed 14,000 gigawatts by 2050. That is more radical than its previous estimate. Why? Because everybody is so optimistic about the future of new energy, mainly due to the decrease in the cost of electricity from new energy. According to a report from Bloomberg New Energy, between 2010 and 2021, the levelized cost of electricity, or LCOE, of the whole world's large PV power stations decreased by 84% on average. To achieve the estimated target and speed up the replacement of fossil energy, the LCOE of PV is to be reduced further. How can we achieve that? What are the major factors? With PV modules, we get high power, high efficiency, high reliability, and high power generation. The 600 watt plus high power module has all these features that can result in a lower LCOE. We know that the power of PV modules has increased. With the introduction of many new technologies over the past few years, the overall PV power has increased much faster than before. The improvement of module power is the core element to reduce the LCOE of PV. In March 2021, China Solar released the Vertex 600 watt plus ultra high power modules. And that created a new era for the whole industry. In May 2022, more than 10 module companies showcased their new 600 watt plus products at Intersolar Europe. Some of these companies were from China. At Intersolar Latin America in August, nearly 30 module suppliers exhibited 600 watt plus products. High power modules have become the mainstream. According to a forecast by PV InfoLink, in 2022, the capacity of 210 side batteries will reach 309 gigawatts, and the capacity of modules will reach 344 gigawatts. Currently, the newly built capacity is basically based on 210, with backwards compatibility. With comprehensive improvements and the maturity of the ecosystem, the supply capacity of 600 watt plus modules is sufficient. What value can that bring about? First, high power. Compared with the traditional module, they can increase power by about 100 to 125 watts. Second, efficiency is very high, plus it can also improve the conversion efficiency by 0.3% to 0.5%. Also, the most important part is low voltage. The combination of these features can greatly increase the power of the stream, thus reducing the initial investment of the PV system. How much can the power of the string be increased? We have made a comparison here between the traditional module and ours at a temperature of minus 20 degrees C plus a voltage of 1500 volts. In our product, the number of modules in each string can be reduced by 2, while the power of a single module can also be increased. This way, the power of each string can be increased by 34%, that is 4.7 kilowatts here. The increase of power in the string can greatly reduce the quantity of cables. According to third parties, our product supports 2 installation methods, which use flexible or fixed brackets and single-axis solar tracking brackets. The third-party Fraunhofer has performed an assessment on our 600-watt plus system. According to their assessment, cost savings are between 0.95 euro cents and 2 euro cents, and the LCOE can be reduced by 1.9% to 4.1%. In addition, we have entrusted multiple agencies to conduct a comprehensive assessment on our 600-watt plus system in different regions around the globe. On the whole, whether it's a tracking bracket or a fixed bracket, the system cost savings can range from 1.3% to 3.6%, even up to 6%, and the power cost reduction can range from 1.9% to 4.1%. Apart from all that, high power and high speed can also save the overall installation and transportation costs. In addition to the ground power stations, the value of those modules has also been widely recognized in distributed scenarios. Take industrial use, for example. We did a calculation on the roof of colored steel tiles in Jiangsu province, China. The system cost can be reduced by a large margin. The 600-watt ultra-high power module can reduce the system cost by around 4 cents per watt. If we look at home use, the savings will also be very large, or even greater. Here we take a roof in Shandong, China as an example, and the cost of the whole system can be lowered by 6 cents per watt. In a nutshell, the performance could be really very high. The performance of those modules has been widely recognized around the globe. No matter whether it's a ground power station, an industrial facility, or a home, our module can always bring about good value. In addition, we have obtained global empirical data for high generation capacity of these modules. We pick 3 projects here. They have different latitudes, different temperatures, and different irradiation conditions. They are in Cologne, Germany, Incheon, China, and Hainan, China. So here, we conducted a practical outdoor test with these modules and the traditional module to look at the data. Over the past 2 years, a lot of data has been collected. In Cologne, Germany, we can see that power generation capacity has increased by about 2% as compared to that of the reference model or module. This place has a high latitude and low irradiation intensity. The gains on power generation capacity from the 210 vertex ultra-high power module is quite great. And in Incheon, we can see this place has a middle latitude and a high irradiation intensity. Compared with the reference module, the 210 vertex module has a benefit in terms of electricity generation. We currently use the 550-watt module here. We can see a 1.5% gain. If it is a 600-watt module, it will be 1.9%. We will continue to collect data for the future, for the whole year. So in Hainan, we could also see a lot of improvements. In Hainan, the latitude is low and the irradiation intensity is moderate. As a whole, we could see our 600-watt plus module has a better performance than the traditional module, and the overall gain in electricity generation is between 1.5% and 2.1%, and that has been recognized by third parties. You may wonder, why is the 210 vertex ultra-high power module better than the traditional module? That is mainly due to its low irradiation performance. At an irradiance of less than 1,000, its power generation capacity is stronger than that of the traditional module. According to data from around the globe, we may need to define a few levels of irradiation. When irradiation is less than 800, the overall power generation capacity of the 210 module may increase by more than 1.4% or even up to 2.2%, which is the largest in power generation. So, in the range of 800 to 1000, the power generation of the modules is about 0.8% higher than that of the traditional module. When it is greater than 1000, the overall power generation capacity is equal to the traditional module. In certain places and times, it could be 0.16% lower. So what are the proportions of power stations at these irradiation levels around the globe? Let's look at the time proportions and power generation in typical regions around the globe. Clearly, we could see the power generation of our module has a benefit over the traditional module because the instantaneous irradiation differs from place to place. The total accumulated irradiation and the proportion of hours in each irradiation range also differ. However, it seems that the proportion of hours with instantaneous irradiation intensity under 1000 ETP areas is between 90% and 99%. Therefore, the power generation advantage of our module is always clear. Even in Queensland, Australia, the region with the highest annual cumulative irradiation, high instantaneous irradiation accounts for only 10% of the whole year, and the single watt generating capacity gain is still as high as 1.3% around the year. We can see the benefit is very clear around the globe. Finally, I want to talk about the progress of our module in terms of reliability, balancing, and compatibility. As you know, the final use of the module is in harsh environments outdoors. So apart from the standard static load testing, our module has been subjected to a standard test plus 5 stringent tests. The standard test is a standard static load test. Apart from that, we have done uneven snow load, extreme low temperature load, hill impact, extreme dynamic load, and strong wind simulation. Only with high reliability can PV modules provide power generation guarantee throughout the life cycle of the system. These 6 tests show that our module can still maintain high reliability in extreme weather, such as severe storms, extreme cold, snow and hail. In addition, the static load performance has been recognized by third parties, including TUV, UL, and PVEL. In that aspect, it is as good as the traditional module. Here, let me give you more details about strong wind simulation via a wind tunnel. We installed the 600 watt plus module and the traditional module on the same bracket in the same installation manner in the wind tunnel. It can be seen that the 600 watt plus module passed the limit test of 62 meters per second. That is equivalent to a Category 17 hurricane. That is very rare. So it can be said that the 600 watt plus module is safe in most scenarios. The 600 watt plus module is larger in size. How can we assure that its high reliability and high load are available in all scenarios? We have conducted research from a few dimensions. The first is about the module itself. As the area of the module increases, we have made some changes to the design of the module. The profile of the module optimized by expanding the cavity. That is very clear. Also, the thickness of the C-plane of the module is also improved. This way, the load capacity of the module can be greatly improved. We also care about the whole system As we know, the safety of the PV system depends on its weakest link. The weakest link is always a joint. Therefore, we have tried to increase the area of the bolt washer that can increase the effective contact interface between the string and the bracket, thereby increasing the bearing capacity. Of course, not every module can be optimized this way, because some modules are limited by the entire width of the C-plane, but the 600 watt class module can use larger bolts. In addition, we support the high load connection mode of the bolt and pressing block that can provide double protection in regions with heavy winds. So in terms of the module itself and the whole system, we can ensure high quality, high reliability, and high financing worthiness of this 600 watt plus module, which has been recognized by authoritative third parties, including PVEL, BNEF, PVTech, and RUTC over the past 2 years. So in terms of inverter matching, we have also done a lot of research. Now we can cover all scenarios with 238 inverters from 22 mainstream brands around the globe. And inverter makers have all adapted their products to our 210 Vertex. In addition, we have made a tour website where you can inquire about the matching relationships between 210 modules of different makes and also different variants under different scenarios, and that can save you a lot of efforts. In terms of tracking brackets, we have tracked 14 first-line brands around the globe and made comprehensive matching. That is already 90% done around the globe. It can be said that most of the tracking brackets can be matched with our module. Currently, the 210 module has covered the whole world, and the global application cases of our module can be found in different environments, including mountains, waters, and flatlands. It's suitable for both industrial use and home use. Up to now, 30 gigawatts of our 210 modules has been shipped across the industry. The shipments of 210 modules have reached 50 gigawatts. Such modules have been widely recognized by customers. We have a plan for building our bases around the globe. By the end of this year, our planned capacity is 65 gigawatts for modules and 50 gigawatts for batteries, so supply is not a big issue. So let me make a summary. The total shipments of our modules has exceeded 100 gigawatts, and the 600 watt plus module has become the mainstream. Also, the 600 watt plus module features high power, high efficiency, and high power generation. By deploying this module, we can create a new way to reduce the LCOE of PV by 9.1% to 4.1%. This module is suitable for global applications. I'm sure it will make contributions to our dual carbon goals. Well, that's all I want to say here. Thank all of you for listening. Thank you, Mr. Chen, for your sharing. In the PV sector, we want to improve efficiency and lower costs. The 600 watt plus module will make a bigger difference going forward. Now, let me give the floor to Mr. Yuan from Growatt. He will talk about the distributed full scenario solutions to help achieve the carbon peaking and the carbon neutrality goals in China. Now let me give the floor to Mr. Yuan.
Ladies and gentlemen, good afternoon. First of all, I would like to thank the organizers for your invitation. And today my topic is distributed full scenario solutions to help achieve the carbon peaking and carbon neutrality goal in China. And today I will cover 3 parts. First, I will review the industrial background. And secondly, I will introduce Growatt solutions. And then I will briefly introduce you about our company. And first of all, the entire distributed PV industry in fact, is now facing a very good opportunity. And the biggest one is a carbon peaking and carbon neutrality goal in China, aka the dual carbon goal. And actually, this goal was put forward by President Xi Jinping last year to build a new power system featuring new energy. It is actually for the first time that the priority of new energy as a main source of power has been raised. And the second opportunity is the county-wide PV promotion plan put forward in June last year, which is a good and favorable policy for the entire distributed PV industry. And if we're going to meet the dual carbon goal, I think we have two important paths. The first one is that our entire energy consumption should be electrified. And secondly, the electricity should be generated with renewables. So we could say that it is foreseeable that there are two certain scenarios in the future. First, our new energy market, including wind power and PV market, will surge in demand. And second, because our new energy resources, including wind power and PV and solar power, they are intermittent. So it's a big trend that the wind power and PV will be used for energy storage in the future. That means the energy storage market will also surge. And of course, opportunities always come together with challenges, especially for distributed PV providers like us. The distributed PV panels are used on roofs of residential buildings, rural areas, or industrial and commercial buildings with the complicated application scenarios. For example, roofs in rural areas tend to be different in size, and the installation systems cannot be copied. And then the roof structures of some industrial and commercial buildings are also varied from each other. And there are some electricity consumption environments, such as some power grids of weak current in rural areas, and in some factories, they tend to have some overload issues. All of these will pose challenges to us. In addition, as distributed PV industry is becoming more and more accessible to the general households and to other sectors, the requirements for the system safety and security is getting higher and higher, including lighting protection, fire protection, power leakage protection, and some power quality requirements. Another challenge faced by us is the distributed nature of our industry, because the layout of this industry is quite scattered, and also the whole distribution of these PVs are located in some remote sites, which makes it really difficult for us to visit those sites very often. So we need to rely on the intelligent operation and maintenance. And now I'm moving on to the second part and talk about GROWA's solution. First of all, actually the whole distributed four-scenario solution includes two parts, PV and energy storage. And the PV includes application of PVs on residential roofs, in the public buildings, industrial and commercial roofs, or the roofs of the government agencies. Another aspect is the user-side energy storage. For example, for those rural residents' roofs, GROWAT actually can provide a safe and reliable small-scale product solution for the whole household PV grid-connected system. And we have a very complete product matrix. We have single-phase and three-phase products covering the whole power range, and we can cover from as small as 750 watts to as large as 50 kilowatts. The comprehensive product matrix aims to meet the complicated application scenarios of different sizes of residential roofs in the rural areas. Therefore, our solution is very flexible here. In addition, for the mainstream high-power components on the market at present, including the 1A2 and 210 components, at GROWAT, we have already introduced this high-current inverter as early as last year, which can perfectly match the 1A2 and 210 components. And for public buildings of the CPC and for the government agencies, or the industrial and commercial factories, we can also provide tailor-made products of 1100 VOC according to the local condition. We also have 1500 VOCs. And for the 1100 VOC products, we can go from 50 kilowatts to 150 kilowatts. And for the 1500 VOC products, we can go from 175 kilowatts to 253 kilowatts.
And now we have also seen a trend that is the roofs of some large industrial and commercial plants will directly adopt the project of a direct connection to the central power grid, and it will adopt the 1500 VOC product, which are originally positioned for the large-scale ground power station. So the advantage of this kind of deployment is to save the investment cost. And when it comes to the development of distributed PV, because it is more accessible to general households and segments, so we have seen greater and higher requirements on the safety. So in this regard, we've done a lot to improve the security. On the one hand, we have built-in level 2 lightning protection of product, and on the other hand, we also have the high precision leakage protection, which is to protect and ensure the personal safety. And in terms of safety, another particular important measure for us is to do the fire protection. In the inverter, we have a built-in AFCI. It is the arc fault circuit interrupter module, which can avoid the fire of the power station, because 40% of the fire accidents in our PV power station are basically caused by the arc fault on our DC side. And with the AFCI arc fault circuit interrupter module, our inverter can directly detect the arc fault at the DC side. If any arc fault is detected, our inverter will immediately take actions. For example, it will cut off the inverter circuit so as to avoid any potential fires. That is why our inverter is equipped with the arc fault circuit interrupter module, AFCI, which can help us do the fire prevention. Viewing from the development of distributed PV industry in the first half of this year, you can see a general trend here. The industrial and commercial sector has developed particularly well this year. And Growatt is also following the trend. We are riding on the tide. We have also launched a full range of high-power models that can match with 122 and 210 components, covering a power range of 100 to 150 kilowatts. For our module, we are the best in three perspectives. First, our power density is very high. Second, our single unit power is very high. For 400 VOC, we have 125 kilowatt series, and for 480 VOC, we have a 150 kilowatt series. In terms of PV series, we also have two. One for 1A2 components, and another one is called X2, matching 210 components. And here we have listed a simple design solution for a 1 megawatt AC unit. By adopting 122 kilowatts 1 megawatts AC unit to compare with 100 kilowatts plus 110 kilowatts. If we're using this inverter we provided, we can save the cost of one or two inverters. And here I would like to briefly analyze the value of this 125 kilowatts product. Let me give you an example. It's an industrial park in Guangdong province. So the volume ratio is said to be 1.156, and the inverter is used here. So we will use 8 sets of 125 kilowatts products. To compare with 110 kilowatts products, we can save 0.01 RMB per watt for the whole system. And we can also see the comparison conditions here. We have the same condition for the comparison. For example, the components are all the same, and the junction box are all the same. And we also have exactly the same volume ratio. So on this premise, we can save 0.01 RMB per watt when using our products. But we also face a problem here in the second half of this year for this 125 kilowatts product.
it can surely help us reduce the investment cost. However, due to the shortage of this HPT module in the second half of the year, the delivery time would be very long. So we also respond pretty quickly and have launched an alternative solution. And this alternative solution is to use 60 kilowatts products combinations. And the biggest advantage is that it's super flexible. The MPPT current is 52A, and it can be flexible matched with both 1A2 and 210 components. And the second advantage is high cost efficiency. Our MAC 60 kilowatts inverter can support the access of 50 square meters lithium cable, which can save the cost of cables. Then in terms of reliability, we are using fully imported inverter HPT module. And the imported module is efficient and stable. We can also deliver it very quickly. And in terms of convenience, the 60 kilowatts inverter is very light, only weighing at 52 kilograms. So it will be very convenient for us to install and transport this kind of inverter on the industrial commercial rooftop. And here I've also made an analysis of the value comparison. Here is an example, industrial park factory in Shandong province. And the volume ratio is designed to be 1.16. And if 60 kilowatts products is used, we will use 16 sets. And here is a comparison. We are using 60 kilowatts to compare that with 110 kilowatts module. And we can see that we can save 0.04 RMB per watt when we are using the 60 kilowatts products combination. Moreover, in terms of the industrial and commercial PV energy storage, in the second half of this year or the Q3 2022, we will launch a solution in this regard. At present, when it comes to the industrial commercial energy storage, we have made two main application scenarios. One is the energy time shift. That is, by increasing energy storage, the excess electricity generated during the peak of the power generation will be stored in the cell. And then when the electricity consumption peaks at night, the cell will be discharged. So in that way, we can save the electricity generated by PV cells during the day. And then this electricity can be used by people at night at a relatively lower price. And some of the factories will actually use cheap PV electricity all the time, so the electricity bill will naturally be reduced. And last year, the authorities have also changed the domestic electricity price. They have widened the peak-trough price difference. And they also set a peak electricity price which was 1.2 times of that of the general electricity price. So under favorable circumstances, in fact, the mode of peak-trough arbitrage is already existing in the industrial and commercial sector. So the industrial and commercial energy storage can bring concrete economic benefits if we can utilize the price difference in the peak time and the trough time. That is also one reason why we want to introduce PV solution in industrial and commercial sector. And we are also providing our solution featuring generation and storage to maximize our customer values. And our customer value includes 4 perspectives. First, high energy efficiency. It means that the charging and discharging efficiency of our cell is very high, and we are also adopting the series design. We have multi-channel MPPT design to reduce the loss of mismatch. And the flexibility is also very good. We can install our product on the wall or in a tower, and the series current is 16A, which can adapt to high power components. And for the sake of safety, we adopt the same fuse-free design as our series inverter, and we also adopt the IP65 design of the whole product. And the AC/DC side was protected against lightning, and the function of arc protection was also included. In terms of intelligence, it's basically the same as our PV inverter. We can do intelligent series monitoring and intelligent IV curve scanning. In addition, we can also provide intelligent reactive power compensation for users in industry to avoid fines caused by excessive power load. Finally, I would like to share with you some of our solutions of intelligent monitoring and operation and maintenance. At present, we have developed this kind of cloud platform which has been used in more than 1.4 million. So it means that we have at least 1.4 million users of this cloud platform. And our entire operation and maintenance system will scan the running status of our equipment online 24/7. And we will also conduct intelligent one-click diagnosis, analysis, and early warning for the power stations. And our monitoring operation maintenance plan include two parts. First, we have this monitoring equipment. We have a variety of such monitoring methods and communication methods, including data sticks and data collectors. In terms of the cloud platform, we have the mobile apps and web servers, including our OSS operation and maintenance cloud platform. And we also have this intelligent IV curve scanning. It can improve our fault handling efficiency. It will also help us to analyze the IV curve of the PV array. And through analysis, we will output a diagnosis report so that we can improve our fault handling efficiency during the operation and maintenance of the power station. In addition, by means of intelligent operation and maintenance, we can improve the efficiency of the operation and maintenance so that we can save the maintenance cost as well. And last but not least, I would like to give you a brief introduction of GrowWatt. At present, in GrowWatt, we mainly focus on new energy and transaction distribution. And our entire business segment includes four sectors, namely PV grid connection, energy storage, intelligent charging pole, and smart energy management. So, viewing from the data of the past development, including the forecast of the future, we can see PV inverter and energy storage inverter will both maintain a very high CAGR. In addition, in terms of our overall business scale, we have already had applications and layout in more than 150 countries and regions around the world. And our inverter capacity is 3 million sets per year. And our cloud platform has already embraced over 1.4 million users. We currently have more than 4,400 employees, and among them, more than 500 are R&D engineers. And the R&D investment accounted for 5.6% of revenue last year. In the case of the photovoltaic inverters, you can see that in 2021, in terms of the shipment of PV inverters, we've ranked among top 3. Especially in the area of residential rooftop PVs, we have maintained on the top for 2 consecutive years in terms of the shipment of the inverters for residential use. And we believe that in GrowWatt, we have 4 strengths to achieve dual carbon goal. The first one is our brand strength. We rank the first in terms of the household inverter shipments, and rank the third in terms of the PV inverter shipments. And we are also providing the energy storage solution. In addition, we are also the only enterprise in China that has already shipped the solution of integration of storage and charging at the same time. And we are also providing the smart energy management solution for household and industrial parks. And during the past 10 years, we have already got the channels to reach out to the villages and counties and towns. We have more than 10,000 frontline installers. And for services, we have this hybrid services featuring both online and offline integration. And we have already had more than 100 technical service personnel of this kind. And we also have more than 100 mobile service vehicles. In addition, we have trained more than 1,000 authorized operation and maintenance service engineers for the whole industry. And they can also serve as a supplement to our own service force. And here are some of the cases. I will just briefly talk about it. The first case is a PV project in Zhixi Garden, Longyou, Zhejiang Province. This project has a very good economic and social benefits. It was done in 2016. And actually, this project is a most primitive model for the county-wide promotion of PV in China. And the second example is this low-carbon industrial park that will help the Dongguan government to build. And this project is called Dongguan Silicon Valley. This project is located in the Pearl River Delta. So relatively speaking, the proportion of its self-use electricity will be relatively high, and the electricity bill will also be high. So the ROI for this project will spike, and the time to recover the investment will be short. We have many more cases. For example, we have the case of helping rural revitalization in Jingzhai, Anhui Province. And we also have some other household projects. I will skip these examples. In addition, in terms of industry and commerce, PV has basically gone into thousands of industries and sectors, including government buildings, industrial parks, schools, and some commercial buildings. And basically, PV has rolled out in an all-round way, starting a new era of zero carbon emission. That's all for my sharing today. Thank you for listening. Thank you, Mr. Yuan, for your sharing. In 2023, distributed PV market will be the most important pillar for the PV industry, and we hope that all of us could join hands together to realize the dual carbon goal. And now let's give the floor to Mr. Yan Haibing, worked for the TW Solar. And he may mainly focus on the positioning of the product and analysis of products in that industry. And his topic is the key technologies for TW Solar's shingled module.
Dear leaders, dear friends online, my name is Yin Haibing, and I work for the Product Management Department of TW Solar. I want to thank TwinForce for giving me this opportunity to make this presentation. Today, I'm going to talk about some key technologies for our company's single module. I will take a popular product as an example so that I can cover more details. Those details can give you a better understanding. This product is 5C in our Terra series. This product supports single and double waves. As you can see from this page, this product 5C can be configured based on actual applications to support either single waves or double waves. Mass-produced 5C single-wave modules can go up to 555 watts, and the mass-produced 5C double-wave modules can reach 550 watts. You can see from this table that 5C uses the 210 battery cell. 5 long strings are arranged in the design. The overall size is 1096 by 2384 millimeters, which is consistent with the 210 5-string configuration commonly found on the market. For a single module, adjusting the size is quite easy. However, we choose the same size as the 5-string module on the market in order to make sure that customers don't need to adjust their power station designs because of the size of our products. We performed a benchmarking test here with some modules that can be found on the market. The output power of the current 210 5-string configuration is about 545 watts. The 182 6-string configuration also has the same power level. The ratio of 545 to 550 is about 8 to 2 around the market. Our single module can squeeze more battery cells in a limited space, so the output power might be slightly higher than the products from other companies, and the difference is about one level. Our ratio of 550 to 555 is basically 5 to 5. Now, let's take a look at the single module. In fact, single modules have a long history. Back in 1954, the Bio Labs invented the crystalline silicon solar cells. Then, in 1956, the DIXA team applied for a patent on the single structure. So that is the early part of the history. In 1971, China launched its first satellite Shijian-1, which used 16 single arrays as the energy source. Anyway, the single structure has been around for quite a few decades. In the past, it was mainly used for aerospace. What is the primary difference between a single module and the half-cut module? It is mainly about the multi-cut technology. Regarding that, I have to mention the issue of cutting. Compared with our peers in the industry, we got involved in lossless cutting earlier with our single module, so we have more insights in that aspect. With our single module, we need to perform more lossless cutting. Generally, people cut a battery cell into 2 pieces, but for our single module, we cut a battery cell into 6 or even 7 pieces. That means more loss. To solve this problem, we started our research on lossless cutting quite early. As you can see from this image, the surface of the whole battery cell under lossless cutting is smooth and even. In terms of mechanical strength, lossless cutting brings a 37 megapascal improvement versus lossy cutting. So why do we need to use the multi-cutting technology for our single module? Why is the industry shifting from the whole pieces to half cuts? Because as the number of battery cells increases, the current of a single battery cell in the whole module will also keep increasing, and the current loss will also rise. In order to reduce the current loss, the battery cell can be cut into 2 pieces. The single structure is based on the same principle, but the single structure has gone further. In our understanding, with half cuts, the current may still be too high. To further reduce the current, we choose to have more cuts, and that works. In terms of reducing the current loss and overcoming thermal effects, we have seen a lot of improvements. Another big difference is about the connection method. At present, most modules on the market use welding for connections, and the welding temperature is about 200 degrees C to 220 degrees C. We use flexible connections for single modules. We use glue to bond the battery cells and realize current transmission through the conductive glue. With the conductive glue, the thermal setting is basically between 160 to 180 degrees C. And according to the Harting curve, its 180 to 160 degrees heating interval is quite short. The overall average temperature should be around 100 degrees C. That gives the single module a better performance versus the conventional module in terms of handling thermal stress.
在这一页我们就可以看到胶水的这个情况。
First, the thermal stress is very small. Second, glue is used for bonding, and the glue provides some flexible space. On this page, you could see the glue. In transportation and handling, the module may be subjected to extreme or external impacts and shocks. In this case, the glass will be bent. With bending, there could be a limited bending space because of the metal materials. Once the bending is excessive, cracks may be formed and the module could be damaged. That is a big headache for many installers. SPIC, the 5 major installers and the 4 startup installers, plus EPCs for home-use products, they all have encountered this problem. In the PV sector, there are strict standards on cracks for modules delivered from the factory. I suppose all the companies can meet those standards. However, when modules are transported and installed by migrant workers, operations may not be so standard. I'm not showing any disrespect for migrant workers. I'm just saying that is a common issue. The single module can tolerate some flexible deformation under stress. In other words, stress can be released. So in practice, the probability of having cracks with our single module is much lower than with welding modules. We have done some verification with third-party labs. When the single module is used outdoors, it will encounter extreme harsh conditions, especially in areas like North China or North Europe. These areas have quite cold winters, usually accompanied by strong winds and heavy snow. What will the performance of our module be in extreme weather? We conducted tests with third-party labs. You can look at this picture on the right, and you will see how we checked for cracks under different temperatures and different loads. At -20 degrees C, a single module has a clear benefit over half-cut modules and a load of ±3600 pascals, 5400 pascals, and -24 pascals, but the difference is small. When we turn to a temperature around -40 degrees C, the stress between molecules increases. Under this condition, when we perform mechanical load testing, we'll find that the single module and the half-cut module have a large difference in power loss. The attenuation of the single module is about 0.3% under mechanical load testing at a temperature of -40 degrees C, while the half-cut module can go up to 9%. So that is the performance of the single module under extreme weather, like heavy rains or snow. In normal conditions, the environment is not that harsh, so we have actually done a lot of experiments, a lot of mechanical load tests when the snow load and the wind load are not so heavy. The first one on the left is a load test of ±1000 pascals for 5,000 cycles. The second image is for a test under ±15 pascals with 1,000 cycles and 2,000 cycles. As you can see from the table, the performance of our single module is basically around 0.3, and that is pretty good. When we develop clean energy, we want to ensure it is clean. PV is clean, and PV provides clean energy, and we care about the future of Earth. The life cycle of a PV module is often 25 years. At the end of its life cycle, we need to consider how to dispose of it. Currently, there are two methods for recycling PV modules. One is the physical method, which breaks the glass, burns the EVA backplane, and then leaves some glass debris. As for the pieces of battery cells, they are melted, left unhandled, or reused later if possible. The solder strip is removed and handled as scrap metal. We know that there is a thin lead layer on the solder strip, and this layer is quite volatile. Lead, which is heavy metal, can enter the atmosphere quite easily. If lead is not cleaned and properly handled, it will have a severe impact on the environment. It has a damaging effect on children's nervous system, and that's really bad. The other method depends on chemical extraction and electrolysis. However, that also pollutes the environment. PV should be clean. How can we use a dirty method to handle what is left of a PV module? That is not how we go about environmental protection. When we designed the single module, we tried to eliminate all the solder strips. As you can see here, the front of the single module does not have any solder strips. We only keep some bus bars on the back. By design, 0.3 kilos of solder strips can be saved for each module, and the lead content can be lowered to a very low level. The reduction of lead could be 60%. That is the contribution of the single module to the environment, and we will continue on this path to eliminate all the solder strips. The pandemic is still here with us, and the war between Russia and Ukraine is still going on. Overseas shipping costs are increasing. In response to that, we have come up with a B30 frame for the single module to optimize the mechanical loading performance. Because of the introduction of B30, we now can support 36 modules on a single support, and the installation capacity of the whole cabinet is about 0.396 megawatts. If we calculate on the basis of $10,000 per cabinet, we can save nearly 15,000 yuan per cabinet. Next, let me show you some projects and our roadmap for our single module. Currently, we have a few single products, including 5C, S6, 5E, and 5K in the Terra series. Among them, 5E and 5K are mainly used for home rooftops overseas. 5C is for industrial rooftops or startup ground power stations overseas. S6 is mainly for large ground power stations here in China. In the second half of this year, we'll launch our 210N product. Our company has been around since 2018, and we have set up a presence in 34 countries and territories. Our products have been well received on the market, and we hope that we can make a bigger difference worldwide. We have a presence in Brazil, Australia, Germany, and France. We are working to expand our business of our single modules around the globe. Now, let's look at a few projects. All these projects use our single module. Our single module can work perfectly with our self-developed flexible brackets that can further improve performance and reduce costs. This is a unique water surface power station project we have done. Going forward, I'm sure we can do our bits in the PV sector, and that's gonna be very good for the future of humanity. That's all. Thanks a lot. The single structure is one of the most competitive structures on the market. Thank you for your sharing. Now, let me give the floor to Dennis He, an analyst from TrendForce. Let's talk about the PV policies and the demand in 2023.
Hello there. I'm Dennis He Wenhui, analyst from the New Energy Research Center of TrendForce, and it is my great honor to share with you here about the policies of the key regional markets in the world in 2023 and the forecast of the demand for PV. And the global pandemic has been plaguing the PV supply chain in 2021 and 2022, and the price of the components still at a high level, and the global PV installed capacity has not been fully released in 2022. Against the intensified energy crisis in Europe, countries have adjusted their energy development strategies and put the development of renewable energy on the agenda. And with the massive release of the capacity of silicon materials in 2023, the prices of all links in the industrial chain have returned to rationality. And the TrendForce predicts that the global demand will continue to be strong in 2023, and the newly installed PV capacity will reach 326 gigawatts. However, due to the pandemic and other factors, the global economy has fallen into recession, and the financial subsidies of various countries for PV projects may be reduced or even cancelled. And now, TrendForce will analyze the 4 regional markets in the world, namely Asia-Pacific region, Europe, America, and Middle East Africa, and interpret the main driving factors behind the growth of PV installed capacity in each regional market. And as the largest PV market, the overall Asia-Pacific region shows a steady growth trend in PV, and the total installed capacity will exceed 178 gigs in 2023. China, India, and Australia are the main markets for newly installed capacity, and India's market accumulated a large number of projects under the construction of 2022. And the market officially entered in a period of rapid development, and it is also expected that in the next 3 years, it will attract the peak of centralized grid connection. As a mature market, Japan and Australia show steady growth in demand. Thailand, Malaysia, Philippines, and other markets are driven by policies to increase this according demand. And now we will subdivide it into several different segments and to interpret each of them. In China, it is estimated that the newly installed capacity will reach 130 gigawatts in 2023, and in the first half of 2022, the overall newly installed capacity will double, and the installed capacity of the second half of 2022 is expected to surge. Under the influence of the rising electricity prices and normalization of power rationing, distributed installed capacity has achieved steady growth. Mega projects of wind and solar power and the market-based photovoltaic ground power station are progressing smoothly, ensuring the centralized installation demand in China in the next 2 years. And at the present, 31 provinces in China has issued the 14th five-year plan for new energy development, and the installed capacity has exceeded 831 gigawatts during the 14th five-year plan period. According to TrendForce, during the period of 2022 to 2025, the future potential for PV installed capacity will be about 423 gigawatts, and the average annual installed capacity will exceed 100 gigawatts. And mega projects of wind and solar power is progressing smoothly, with nearly 90% of the first batch projects starting construction. It is estimated that the grid connected quantities in 2022 and 2023 will be about 46 gigawatts and 51 gigawatts respectively, with a total amount close to 97 gigawatts. And the second batch of projects are planned to focus on the construction of desert and Gobi area, with a currently announced installed capacity of 165 gigawatts. And India is experiencing a period of rapid development. It is estimated that installed capacity of PV will reach 14 gigawatts in 2023. At present, the PV installation are mainly large-scale ground power station projects, accounting for about 80%. India's power structure relies heavily on coal for power generation, accounting for about 55% in 2022. Due to the power generation gap caused by the decline of imported coal supply, the Indian government now promulgated a plan of replacing 30 gigawatts of thermal power generation with renewable energy in 2026. In the presently,
At the present, it's expected that India's new power capacity will be tilted towards renewable energy in the future. In August 2022, the Indian government has also abandoned the original target of 500 gigawatts of non-fossil fuel installed in 2030, and they have turned to a more flexible and rational 50% of non-fossil fuel power instead. And in terms of policy, BCD tariff has been officially implemented in April 2022, with 40% and 25% BCD tariff levied on imported components and batteries, respectively. At present, India strongly supports local PV companies so as to reduce their dependence on imports. However, at present, the domestic PV manufacturing industry in India is not mature, and the installed demand mainly depends on imported components from overseas. And also, it cannot satisfy the local demand for installed capacity. Without an introduction of any new policies, India's demand for PV will slow down in 2023. And in Australia, the market expects the newly installed capacity to reach 6.5 gigawatts in 2023. Looking back at first half of 2022, Australia was affected by the high price of components, and the demand for centralized installation failed to be released as expected, with the main increase being contributed by residential households. It is estimated that in 2023, the installed demand of large-scale ground power stations will pick up. In Europe, the European market has maintained a high prosperity since the outbreak of the Russia-Ukraine war. It is expected that the demand for PV installed capacity will be further released in 2023, and the newly installed demand will reach 73 gigawatts. And the aggravation of the energy crisis has led the European Union and European countries to introduce corresponding policies to improve the development goals of renewable energy, significantly enhancing the bidding capacity of PV, wind power, and other new renewable resource projects. It is expected that the market demand will be strong in 2023 and expected to grow even further. Due to the 1.5 to 2 year construction period of a ground power station, the influence of current bidding expansion will gradually be seen in project installation until 2023 and 2024. In addition, under the energy crisis, a high electricity price combined with the financial expansion, all of these promotes rapid growth of distributed installed capacity in the short term. Apart from the government-led part, the rise of private PPA projects has strengthened the market-leading power. Financial stimulus, bidding, and PPA will support the demand of the European PV market in the short, medium, and long term respectively. However, it is still necessary to take into account the European economy is in recession, so that the financial support is forced to be lowered, and the price of the PV modules remains high, thus suppressing the demand as a result. And for Germany, as one of the leading countries in European PV market, Germany will have a new installed capacity of 12 gigawatts in 2023. Looking back at the installed capacity data from January to July 2022, the newly installed capacity is about 3.7 gigawatts, up by 15.6% year on year. And the main reason why there is no obvious growth in 2022 is because of the high price of the components and the labor shortage. And in response to the energy crisis, Germany has made a series of adjustments to its energy planning. In 2030, the proportion of renewable energy generation will be raised from 65% to 80%. EGG 2023 updated the cumulative installed PV capacity target, standing at 215 gigawatts in 2030, which is 15 gigawatts higher than the previous period. And the original nuclear energy phase-out plan raised by Germany will be delayed to April 2023, during which the nuclear power generators will be on standby as backups to ensure energy security. It is reiterated that the coal will be phased out in 2035, and the coal power plant phase-out will be postponed to make up the power generation gap caused by the shortage of natural gas, thus alleviating the power supply pressure during the peak period of electricity consumption in winter and summer. And in terms of policy, renewable energy surcharge, which was originally scheduled to be cancelled in early 2023, was officially ended on July the 1st, 2022. In terms of on-grid electricity price, EGG 2023 divides PV power generation system into the following standards: self-use, surplus electricity, on-grid, and all on-grid. The former electricity price is 1.4 to 3.8 euros.
cents per kilowatts. And actually the government encouraged the first on-grid standard, so as to reduce the transmission pressure of power grid brought by the new energy grid connection. And in 2023, all the 40 kilowatts to 1 megawatts rooftop PV system can choose the above two models of grid connection. And in Spain, as of the end of 2024, it will simplify the EIA process for PV projects under 150 megawatts. Floating PV projects are also included in the field of public utilities, and they are eligible for a 25-year franchise. And from 2023 to 2025, the investment in power grid will be expanded to promote the installation demand of the newly built small-scale renewable energy power generation and self-use projects. And since Spain has achieved parity on the power generation side and all kinds of PV subsidy policies have been withdrawn, at present, the main development power of the market comes from the bidding projects planned by the government and the unsubsidized PPA. And since 2021, Spain plans to hold at least 3.3 gigawatts of renewable energy bidding every year, of which 1.8 gigawatts is photovoltaic. In 2021, the bid winning capacity of PV is close to 3 gigawatts and expected that it will be connected to the grid at the end of 2023. And for Netherlands, due to the limited geographical space, the PV market in the Netherlands is dominated by distributed PV installations. And it is estimated that the newly installed capacity will be about 8 gigs in 2023. And the distributed PV will account for 83%. And the Netherlands is also actively deploying the floating power station projects with a cumulative installed capacity of over 180 megawatts. And the Dutch Ministry of Finance has also passed a resolution saying that they will cancel the VAT of household PV project components from January the 1st, 2023, and the current tax rate is 21%. Due to the low lighting resources, the growth of PV installed capacity in Netherlands depends on the subsidies provided by the government. And the net metering plan adopted by household projects will be gradually reduced in 2023 and completely cancelled in 2031. And the industrial and commercial ground power stations are driven by SDE plus policy, with fixed electricity price and non-profit. The non-profit fund is subsidized, and the total amount of subsidy has increased to 13 billion euros in 2022. At present, there are still about 11.7 gigawatts of PV projects under construction. And in America, the demand for installed capacity will accelerate, and it is estimated that by the year 2023, the newly installed capacity will reach 63 gigawatts. The United States, Brazil, and Chile are the top 3 PV markets, and the supply chain constraints and rising prices will be optimized or addressed in 2023. And the PV production capacity will be exempted in Southeast Asia will be exempted for 24 months. That means overall demand for installed capacity in the United States is expected to pick up. In 2023, the newly installed capacity in the United States will reach 35 gigawatts. Looking back at Q2 2022, the total installed capacity in the United States increased by 4 gigawatts, down 12% year on year, and installed capacity in Q2 has been recovered to a greater extent than Q1. And the household PV installation maintained high growth, and installed capacity reached a new high exceeding 1 gigawatts with a year-on-year increase of 37%. And it is expected that installed demand in the United States will pick up further in the second half of the year, and the demand growth will further reflected in 2023. And in the Q3 2022, the United States passed the Inflation Reduction Act, which guaranteed that ITC subsidy, which was originally scheduled to increase stepwise in 2023, would be extended to 2032. And the distributed projects would maintain a 30% credit amount, and the local PV industry would be strongly supported. However, due to the influence of labor costs, technical barriers, and even development of industrial chain, local PV manufacturing industry in the United States is not competitive at present. And in Brazil, at present,
The main increment of PV market in Brazil is contributed by the distributed projects. And we predict that the new installed capacity in Brazil will reach 16.8 gigawatts in 2023. And from January to July 2022, the distributed PV accounted for 65%. And the Brazil's net metering system will be updated in 2023, and the power generation users will begin to bear part of the distribution costs. And the demand for distributed projects will continue to expand in the next 2 years. And in Brazil's 2031 10-year National Energy Expansion Plan, the installed capacity of renewable energy will reach 229 gigawatts in 2031, accounting for 83%. At the same time, the Brazilian government has also raised the planned installed capacity of PV, and the target of the newly installed capacity of PV will reach 32 gigawatts. And for Chile, the predicted installed capacity in Chile in 2023 is about 2.4 gigawatts. Looking back at the newly installed capacity from January to July 2022, the capacity is about 1.5 gigawatts, down by 13.4% year on year. And Chile's market lacks growth momentum. As of May 2022, the installed capacity of PV is in the power structure is close to 7 gigawatts, which is very close to the target set by the authorities in 2030, that is 9.8 gigawatts, with little incremental space. And the last regional market is the Middle East and Africa. And the Middle East and Africa mainly rely on bidding projects to promote the demand for PV installation, and it's estimated that the newly installed capacity will reach 12.6 gigawatts in 2023. At present, the bidding capacity in the area has exceeded 7 gigawatts, and they will have because they have abundant lighting, so it's expected that the future bidding projects will see a sustained growth. So overall, in 2023, the global PV installation will maintain high growth rate. The growth rate of key regional markets will slow down, while the demand for PV installation will gradually pick up. However, due to the global energy crisis caused by the Russia-Ukraine conflict, plus the reoccurring COVID outbreak, all links of supply chain and downstream demand will be compromised, slowing down the global economic growth, increasing the possibility of economic downturn, and there will be uncertain factors in forecasting the current demand for installed capacity. And Europe may be the most affected regional market due to the various problems caused by the energy pressure and inflation. Financial support will be declined, and the future demand for PV installed capacity in the Europe market will take the hardest blow by the global economic downturn. And in addition, the geopolitical uncertainty and the general election of the government will also have a certain degree of influence on the installed capacity of the major global photovoltaic markets in the future. And that is all about my sharing. Thank you for listening. Thank you for your sharing, Dennis. Looking into 2023, the demand market of PV will increase, and we will face greater opportunities. And April, both analysts, April and Dennis, are extracting this data from the TrendForce reports, and you can contact us for more details of these reports. Thank you again for sharing, and thank you again for your support and attending this event. And in the future, we will have some more seminars, and we hope to have you all in the future seminars, and that is all about this event. And if you missed this live streaming, you can watch the replay. And TrendForce will also promote more online sharings. And thank you again for your support and attention. See you next time.